Have you ever stopped to think about how much of our world revolves around connections?
I mean, really, connections are everywhere.
Yeah, think about it.
Yeah,
Your friends, they know other people who know other people. It's like this expanding web.
totally. And then there are things like if you buy something online, suddenly you get all these recommendations based on what other people who bought that also liked.
Or in finance, right? One seemingly small transaction might actually be part of a much bigger pattern of suspicious activity across a whole network.
Exactly. And the thing is, traditional databases, the kind that most people are used to, with their rows and columns, they're not always that great at capturing and analyzing these kinds of complex relationships.
No, they're kind of like trying to fit a square peg in a round hole, aren't they?
Pretty much. They weren't really built with those connections in mind as the primary focus.
And that's where graph databases come in.
Yeah, exactly. They're specifically designed to understand connections. They're all about those relationships.
So if the connections between your data are just as important as the data points themselves, then a graph database is the way to go.
Definitely. Because it allows you to model and explore those relationships in a much more natural and efficient way. You can ask questions and uncover insights that would be ridiculously complex and time-consuming using those older systems.
Which brings us to the topic of this deep dive, Amazon Neptune Analytics.
Yeah, Neptune Analytics.
So if anyone out there is working with just massive amounts of data and it's all interconnected and you need to find insights from that data quickly, well, this is something you should know about.
Yeah, it's really built for that kind of scenario.
So for our listeners who might not be super familiar with it, can you give us a quick overview of what Amazon Neptune Analytics actually is?
Sure. So it's basically a graph database engine, but it's specifically optimized for doing analytics, and it's designed to work really well with those huge data sets.
Okay, and what does it mean that it's memory optimized? What difference does that make?
So memory optimized basically means that the data is stored primarily in memory, in RAM, rather than on slower disk drives. And what that does is it allows for really, really fast query processing.
Got it. So speed is a big deal here.
Huge. It makes a massive difference when you're trying to analyze billions of connections. You can get answers and insights in near real time, which is super important for a lot of use cases.
Absolutely. You need those insights quickly to make decisions, to react to things.
Right. And it's not just about the speed either. It's also about the fact that it can handle these huge graphs with billions of nodes and edges. That scale is pretty impressive.
So it's built for speed. It can handle massive amounts of data. What else makes Neptune Analytics stand out? What are some of its key features?
Okay, so beyond the whole memory optimized thing, one of the really cool features is that it uses a query language called openCypher.
openCypher, okay. And what's special about that?
Well, it's specifically designed for working with graph data. So it's super intuitive if you're trying to find patterns and connections. It's like, imagine you're trying to find all the friends of friends in a social network. With openCypher, that becomes a really simple query.
So instead of having to write these really complicated queries, openCypher simplifies things because it's made for graphs from the ground up.
Yeah, exactly. And it also has a syntax that's pretty similar to SQL, so if you're already familiar with that, it's not too hard to pick up.
So there's a bit of a learning curve, but it's not going to be completely alien to people who've worked with databases before.
Right. Another cool thing is that Neptune Analytics comes with all these pre-built algorithms, like PageRank, community detection algorithms, things like that.
And just to remind our listeners, PageRank, that's the algorithm that Google originally used to rank websites, right? Based on how many other sites were linking to them.
That's the one. And in the context of a graph, it helps you identify the most influential or important nodes. So you can use it to find influencers in a social network, or key products in a recommendation engine, or really anything where you need to understand which nodes have the most impact.
And those community detection algorithms, those are all about finding groups, right?
Yeah.
Clusters of nodes that are more closely connected to each other than to the rest of the graph.
Exactly. So you can use them to find communities in social networks or groups of customers with similar interests, or even identify potential criminal networks in financial data.
So we've got speed, scale, openCypher for querying, pre-built algorithms. Is there anything else that makes Neptune Analytics particularly powerful?
Well, one more thing I should mention is its ability to handle vector search.
Vector search. Now that sounds interesting. Can you elaborate on that a bit?
Yeah, so this is getting into more advanced territory, but basically it allows you to take things like text descriptions or images and convert them into numerical representations called vector embeddings. And then you can use these embeddings to find similar items within the graph.
So it's not just about who's connected to whom, but also about the meaning of those connections or the things they're connected to.
Exactly. It's like, imagine you have a product catalog, and each product has a description. You can turn those descriptions into vectors, and then use Neptune analytics to find products that are semantically similar, even if they're not directly connected in the graph.
So you could build a recommendation engine that suggests products based not just on what other people have bought, but also on how similar the products are in terms of their descriptions.
Precisely. It adds a whole new layer of intelligence to your analysis.
That's really cool. So we're diving deep into all of this because we're taking a look at a new resource that's come out called Mastering AWS Neptune Analytics.
It's a really comprehensive guide to working with this service
And our goal today is to give our listeners a good overview of what this book covers.
and to help them figure out if it's something that would be useful for them, in their work or their projects or just for their own learning.
Exactly. So let's start with the fundamentals. Why should anyone care about graph analytics in the first place? Why is this even a thing?
Okay, so graph analytics is all about understanding relationships in data. And honestly, so many real-world problems are fundamentally about relationships.
Like we were talking about at the beginning.
Yeah, like social networks are the obvious example. But think about things like supply chains, financial transactions, even scientific research. All of these things involve complex networks of relationships.
And by understanding those relationships, you can get insights that you would never see if you were just looking at the data in isolation.
Right. Like in a social network, you can see how information spreads, or you can identify influential users. Or in a financial network, you can spot patterns of fraudulent activity.
Or in a supply chain, you can find bottlenecks or vulnerabilities.
Exactly. The applications are really endless.
So the book, Mastering AWS Neptune Analytics, it really dives into how to use this specific service. What are some of the key things it covers?
Well, it starts with the basics, like how to create a Neptune analytics cluster and load your data.
So it assumes that the reader might be coming to this with no prior experience.
Not necessarily no experience, but it definitely starts from the ground up. It walks you through all the steps of getting started.
Okay, so you create your cluster, you load your data, then what?
Then it gets into the really interesting stuff, like how to query your data using openCypher. It has lots of examples and explains the different clauses and functions you can use.
So it's like a practical guide to actually writing queries and getting answers from your graph.
Yeah, exactly. And it also covers things like how to use the pre-built algorithms, how to do vector search, how to optimize your queries for performance.
And it also talks about how to manage and secure your Neptune analytics cluster, right? Like how to do backups and set up access control.
Absolutely. It covers all the operational aspects as well.
So it really is a comprehensive guide. Who do you think this book would be most useful for?
I'd say it's great for anyone who's working with large interconnected data sets and needs to do analysis on them.
So data scientists, analysts, engineers.
Yeah, anyone who's involved in building applications that rely on graph analytics.
And especially if they're working in the AWS cloud.
Definitely. The book focuses specifically on AWS Neptune analytics, so it's really tailored for people who are using that service.
Okay, so to wrap things up, why should our listeners consider exploring this technology? Why is graph analytics so important?
Well, I think we've touched on a lot of the reasons already, but fundamentally it's about being able to see the connections in your data and understand how they impact everything else.
It's about going beyond just looking at the individual data points and seeing the bigger picture, the network, the web of relationships.
Exactly, and that's where the real insights lie.
And with a tool like Amazon Neptune Analytics, you can do that at scale and with speed. You can get answers to complex questions in near real time.
And mastering AWS Neptune analytics can help you get there. It can give you the knowledge and skills you need to really leverage the power of this technology.
So for all of you listeners out there, if you're dealing with data that feels like a tangled web and you suspect there are valuable insights hidden within those connections, well, maybe exploring graph analytics is the key to unlocking them. What new understandings could you uncover by mapping and analyzing those relationships? Maybe more than you might think.